It begins in a pocket of limestone, a chamber so narrow that even light must bend to enter. Southern France, chalk cliffs, silent hills, a place where time compacts itself into sediment and memory. There, a shard is found, not buried, not broken, but waiting beneath layers of ash and bone. A flake of flint, no longer than a finger, sharp, unchipped. Its edge still glints in the filtered torchlight, like it remembers the hand that struck it. Carbon dating confirms the impossible. 80,000 years old, but no patina, no erosion. It's as if it was dropped yesterday, and it's not alone. In a German valley, beneath an old streambed, another tool emerges, near identical cut marks. In Spain, near the edge of a forgotten coast, a broken core is unearthed, its geometry unmistakable. The tools span nearly 90,000 years. Different cave systems, different Neanderthal populations, yet they all bear the same fingerprint. The stone, not just any flint, a rare blend of silicious chert, laced with trace vanadium, giving the flakes a faint gray-green hue under UV light. When run through mass spectrometry, the story becomes clear. All these tools, scattered across the continent, share one origin: a single vein of stone, from a quarry now buried beneath layers of post-glacial runoff. What surprises the archaeologists isn't that Neanderthals used flint. That's known. What stuns them is that they used this flint again and again, across thousands of kilometers and tens of thousands of years, as if they sought it out, as if they remembered it. But how could memory span generations that left no written word? How could one stone whisper itself forward across bloodlines? Satellite imagery gives the first clue. A high-resolution subsurface scan of the region, part of a larger ESA project mapping geothermal basins, detects a density anomaly below the assumed quarry site. What appears, when overlaid with magnetic intensity readings, is an unexpected void. A perfect chamber, roughly circular, nearly 11 meters wide, buried beneath 22 meters of sediment. Stone veins don't hollow like that. This wasn't collapse. It was absence. Something had been there, something taken, or something left behind. Researchers reanalyze core samples from the old quarry. Tiny inclusions in the chert show microstriations, faint lines, repeating at unnatural intervals. Not biological, not tool-made, more like machined rhythm. But this is Neanderthal-era stone. No machines, no metallurgy. And yet, when those striations are translated into waveform models, they form a pulse, an irregular, slow-beating pattern. Not sound, not language, but timing. The stone may not have just been cut. It may have been conditioned. Back in the lab, a flake replica is 3D printed from synthetic resin. A modern hand holds it, tests it. Even now, in an age of alloy and plastic, the ergonomics are perfect. The flake slides into the grasp like it was made for the modern palm. Not too large, not too jagged, just right. It's not only a tool, it's an interface. And maybe it always was. Anthropologists call them memory objects. Items not passed by words, but by repetition. A stone picked, shaped, passed, and reshaped again. Lineages of behavior etched into fingertips. But this one is different. This one persisted. Other flint sources dried up. Styles changed. Regions fragmented. But the green-hued flint from that hollowed quarry endures. Even late-stage Neanderthals, nearing extinction, returned to it. Even early Homo sapiens, long after Neanderthals vanished, used it at transitional sites, as if the memory of the stone outlived the people who first cracked it open. What kind of material carries memory like that? Not metal, not code, stone. In a remote dig site, a researcher lays out dozens of flint flakes across a white sheet. They are all nearly the same. Different centuries, different tribes. But the edges, the curves, the strike patterns, all nearly indistinguishable. Not coincidence, not instinct. Rehearsal. One flake from an old Belgian cave carries a pattern of heat discoloration, indicating it sat near fire, but was never used, never dulled, intact, preserved, and seemingly intended to be seen, not employed. A totem? A token? Or a signal? As the narration draws close, we return to the quarry. A modern LiDAR drone flies above the region, sweeping in near silence. Infrared picks up faint differences in soil temperature, lines beneath the overgrowth, like veins under skin. But one shape arrests the team, a spiral, carved into the land's memory. Not deep, barely visible, but unmistakable. A slow, curling path, like the twist of a flake as it's peeled from a core. The spiral aligns with solstice light angles. The quarry wasn't just dug, it was designed. Who first taught stone to hold shape? Who first realized that memory didn't need voice? That it could ride along fracture lines and mineral strain? Neanderthals may never have known why the flint mattered. Only that it did. Only that it cut, it stayed sharp, and it fit. And so they carried it across rivers, glaciers, lifetimes. A tool, a fragment, an inheritance, and buried beneath it still, a hollow chamber that remains unentered. Not empty, just waiting. It starts with heat that should no longer be there. Long after the embers have faded, long after the bones have whitened, long after the voices have vanished. Still, the Earth remembers. In southern Europe, thermal satellites scanning for geothermal activity begin detecting something unexpected. Residual warmth in shallow cave systems that have lain untouched for tens of thousands of years. Not volcanic, not tectonic, just warmth. Faint, fixed, and patterned, in the shapes of circles, lines, arcs, too precise for randomness, too clean for erosion. The data is passed to archaeologists. What they find rewrites the floor plan of deep prehistory, within layers of blackened soil, once dismissed as general campfires, lie repeating hearth geometries. Not just places where flames once burned, but arrangements. In one cave, 3 fire pits form a perfect isosceles triangle, each 4.3 meters apart. In another, 5 hearths curve along an invisible arc, their centers aligning with the winter solstice sunrise. Not just shelter fires, orientation fires. LiDAR drones sweep the chamber ceilings. They detect light shafts, carved gaps in limestone that permit a single beam during equinox sunrise to strike one hearth exactly. That hearth contains no charcoal, only stone flakes, those same green-hued flints from the quarry in part 1, deliberately placed in a radial pattern. Some broken, some whole, none sharpened. The message is subtle but clear. This was not for warmth. This was for memory. We think of writing as ink, as character, as sound pressed into paper. But before language, there were placements. Stone beside fire, fire beneath sky, sky upon earth. One researcher labels it paleogeometric syntax, the earliest known use of space as signal. The idea isn't new, but the consistency is. Across thousands of kilometers, France, Spain, Croatia, Neanderthal hearths appear again and again in angular formations. Even when cave topography shifts, even when ceilings collapse, the patterns remain. But how did they keep them? Without rulers? Without charts? How did Neanderthals align their hearths with solstice light angles? How did they embed memory into stone without speech? Modern field teams reconstruct one site using ground-penetrating thermal overlays and solar tracking software. They find something startling. The hearths don't just align to the sky. They amplify it. The arrangement of pits causes light to scatter through natural quartz deposits in the cave wall, projecting refracted beams toward the rear chamber. Not art, not accident, atmosphere. A room that glows when the sky shifts. A living calendar, or a ceremonial memory theater. Inside the central hearth, more flakes, but again untouched. No scrape marks, no evidence of cutting. These were not discarded tools. They were components. When analyzed for trace elements, researchers detect something faint on the flint. Ash layers, yes, but also burnt lichen, animal fat residue, resinous plant compounds. The flakes weren't just left. They were prepared, heated, placed, sealed by flame, like tokens in a rite, like symbols in a fire-coded language. Across 3 continents, every hearth cluster follows a strange rule. The stones are always arranged concave to the rising light. Never convex, never random. It's as if Neanderthals weren't just building fires. They were building mirrors, reflections of memory, guides for return. Not for the body, for the mind. AI modeling simulates heat dispersal from these fire arrays. The result? The patterns focus warmth toward the center of the room, creating a shared thermal space. Anyone within would feel identical heat on all sides. A primitive neurological sync zone. Modern experiments place human volunteers in replicated hearth geometries. Monitored under low light, with silent flames and flint structures, their brain activity changes. EEG patterns show entrainment, rhythmic coherence, lowered inhibition to sensory input. In short, the architecture induces memory flow. Not speech, not vision, but felt memory, embodied, shared. The researchers stop calling it a campfire. They begin calling it a geologic interface. What if this wasn't just survival? What if this was the Neanderthal answer to forgetting? If speech fades, if names die, if stories rot, then stone must hold the shape. Flame must return the rhythm, and earth must be the archive. In one cave near the Black Sea, a central hearth reveals something new. A large slab, unburned, sits in the fire's heart. It's not flint. It's magnetite, highly magnetic, conductive. Why place it in the fire? Some suggest it altered the glow. Others propose it was a lodestone. But when measured, the slab retains remnant magnetism, a faint field that still pulses, aligned with Earth's magnetic north. A hearth stone that remembers orientation. It's as if the fire wasn't built to burn. It was built to point. These fire structures are now being mapped by orbital magnetometry. Satellites not designed for archaeology are suddenly revealing ground patterns invisible from above. Geometries embedded in Earth's magnetic texture. And always, the signal is strongest where flint shards are buried. The flame was only the beginning. The code was beneath it. So when the solstice comes, and sunlight cuts through the cave, and fire touches the same stone Neanderthals placed 60,000 years ago, what glows is not history. What glows is memory, written in warmth, etched in silence, held in the angles of the earth. They expected instinct. They found intelligence. In a small lab built beneath a museum archive in Germany, a group of neuroarchaeologists gathers around a 3D table. On it, flint cores, antler hammers, bone rests. The task: replicate Neanderthal flake tools blow by blow. Not to build tools, to trace the thought behind them. Volunteers, right-handed, left-handed, all untrained, are fitted with EEG caps. Cameras capture every motion. Motion sensors track each micro-movement of shoulder, wrist, knuckle. What unfolds is strangely beautiful. After just 3 sessions, the human hands begin to behave differently. More efficiently, more rhythmically. Even first-timers begin to strike with uncanny accuracy. No instruction, no vocabulary, just repetition. It's not learning, it's entrainment, as if the action itself teaches the body, as if the stone trains the hand. The AI running the simulations begins to recognize something deeper. The patterns of motion are nearly identical across all subjects. Same angle, same force, same anticipatory microflick just before the strike. A motion passed forward through bodies that never met. A procedural ghost, living in limb, not language. But then something stranger happens. One subject, a sleep researcher by profession, exhibits unusual brainwave patterns during the Flint sessions. Her theta rhythms, associated with memory consolidation, show strong coherence with magnetometer fluctuations. But not from her environment, from the quarry, the old stone vein, the one whose flint tools populate thousands of caves across Eurasia, had long since been mapped by satellite. But one research satellite, still running a geologic magnetometry experiment over the region, picks up faint phase shifts, as if Earth's field there is gently pulsing. When correlated with the subject's EEG recordings, the pulses match perfectly, not in strength, but in rhythm. No known mechanism should allow this. The subject is 2,000 kilometers from the quarry. She is holding modern replicas. There is no magnetic equipment in the room, yet her brain and the quarry's stone resonate. Another subject is tested. Same task, same tools, same outcome. This time, the EEG shows a faint anticipatory signal, milliseconds before each hammer strike. Like the brain knows what the hand will do. This isn't just procedural memory. This is shared memory, distributed, tactile, geologic. One theorist proposes something radical. What if Neanderthal cognition wasn't stored only in the brain? What if it was stored in motion systems trained by matter? In this view, the quarry isn't just a source of stone. It's a biological scaffold. Like bees to hexagons, like birds to migration. Maybe humans were drawn to that flint vein not for quality, but because it already knew how to be shaped. Because it taught them, a new AI model is trained, not on neural nets, but on kinematic memory maps extracted from the replication studies. The model is then tested using random stone types. Results: inconsistent. But when the flint type from the original quarry is introduced, the model completes the replication task without input. It strikes correctly, angles align, edge geometry stabilizes. The stone, in a sense, remembers itself. Researchers run deep mineral resonance tests on the flint cores. They find lattice imperfections that, when energized with low-frequency EM pulses, emit tiny, consistent vibrations. Not enough to be felt, but enough to be sensed. Another team speculates that long-term handling of this flint might have subtly affected inner ear balance systems. An interface not just of thought, but of spatial orientation. Touch the stone, feel the strike, move in line. The quarry, they realize, isn't just a place. It's a training system, an environmental intelligence, not active, not alive in the way we understand life, but adaptive over time. A form of cognition that lives in physics. Distributed cognition, not intelligence in the spark and circuit sense, but a system of matter, memory, and motion that trains behavior across generations. A quarry that molds the hand, a stone that engineers habit, a flake that shapes rhythm. The distinction between biology and tool begins to blur. New questions emerge. Did Neanderthals know? Did they understand what they were touching? Or were they simply following a trail laid down in movement? Was the brain merely interpreting what the stone had already asked it to do? In a final experiment, a subject dreams during a post-flint nap. The EEG records high-amplitude delta waves. The subject murmurs a word in her sleep, repeated 3 times. A sound not from any known language, but when processed through phonetic models and compared to the cave registry logs, it closely matches a known paleolinguistic root. Car, stone, to cut, to remember. There are no books in the Paleolithic. There are no words carved in cave walls, but there are flakes, and each flake carries a history of how it was struck, held, and sharpened. A memory, written not in thought, but in gesture, a grammar of fracture, a vocabulary of pressure, and perhaps a syntax we've only begun to read. The brain didn't just recall the quarry, it may have emerged from it. In the final years of the satellite's mission, the data wasn't supposed to matter. The orbital model, designed to simulate Earth's geomagnetic fluctuations across glacial epochs, was already complete. The ice ages had been mapped. The crustal drift lines were accounted for. The polar migrations, charted down to sub-millimeter arcs. It was a cleanup operation now. Tidy up anomalies, close the loop, decommission the satellite. But one anomaly refused to be closed. A pulse barely detectable, centered beneath the ancient quarry, consistent across every epoch. It hadn't moved in 100,000 years, hadn't faded, hadn't changed frequency. It was simply there, waiting. The signal isn't seismic. It isn't magnetic. It isn't acoustic. It's resonant, a low-frequency wave that interacts with no known geologic structure, but appears to modulate slightly during summer solstice each year, when the sun hits the quarry at its highest angle, when the shadows grow shortest, when the air stills, and deep beneath the earth, the pulse persists. Scientists feed its waveform into an AI sonification model, used to turn raw data into audible patterns. The output? Drumming. Not random, not uniform, but pulsed. 3, 2, 1. Pause. Repeat. 3, 2, 1. A rhythm, a pattern, almost a call. Researchers compare the rhythm to hearth arrangements discovered across Neanderthal sites. The correlation is eerie. 1 hearth equals 1 drumbeat. The spacing between fire pits aligns with the intervals of the pulse, like the stones have been placed in answer to something heard, not by ear, but by instinct or memory. At first, they dismiss it as pareidolia, a mind pattern seeking in noise. But further sonification reveals modulation over longer periods. The pattern stretches, then contracts, then stretches again. It breathes, and at no point in 400,000 years of sediment layers is the pulse absent. Even beneath glacial sheets, even through tectonic quiet, even now, one theory emerges, half-whispered, unofficial, not peer-reviewed, not published. The quarry isn't just a source. It's an interface. Geologists return to the site. They deploy micro-resonance hammers, small machines that emit controlled low-frequency vibrations into the stone and measure the bounce back. In most rock, it echoes back like sonar. But here, beneath the quarry floor, the signal absorbs, or more precisely shifts, as if something below is listening and replying, not in echo, but in distortion. Each hammer tap alters the base pulse, not by much, but enough. The signal can be shaped. If you had enough time, if you had enough flint, if you had enough fire pits arranged just so, you might eventually learn to speak back. This realization reframes the entire archaeological record. Perhaps Neanderthals didn't just use stone. They followed the signal. Perhaps the flint vein wasn't just convenient. It was emissive, a beacon buried in the earth, humming through the crust, whispering through matter. Not in words, not in logic, but in pressure, in rhythm, in placement. And Neanderthals, without books, without symbols, listened. Not as scientists, not as mystics, but as something deeper, as responders, hands shaping stone, to reflect the pulse beneath their feet. Fires arranged not to warm, but to mirror what couldn't be seen. The quarry wasn't chosen. It was found, because it called. And now, in the age of satellites and AI, we're only beginning to hear what they may have felt. A long, slow transmission, a pattern older than speech, a resonance buried in stone, not to inform, but to invite. The final test is quiet. A researcher stands alone at the quarry site. Its floor cleared, its edges marked by modern sensors. She holds a single flake, napped by her own hand. She places it at the center, kneels, waits. The signal does not change, but the air grows still, and the instruments detect a fluctuation, a slow narrowing of the pulse, as if the shape has acknowledged her. Not seen, not known, just registered, and the rhythm tightens. 3, 2, 1, pause. 3, 2, 1, again. It is not a message. It is not a mind. It is a presence. Old, buried, patient, and for 100,000 years, it waited for someone to answer. Perhaps Neanderthals tried. Perhaps they succeeded. Perhaps they never left the conversation at all. Perhaps this isn't the end of a story, but the beginning of one we are finally ready to remember.